So I'd like to say welcome to Magnus de Witt from Iceland, and he will tell us about the energy resources and electricity generation in Arctic areas. Sorry. Are you ready, Magnus?
Yes, I'm ready. I hope you can hear me, and give me a second to share my screen. I hope you can see now my presentation.
Yes,
okay.
Thank you.
So first, thanks for inviting me, and also thanks to the previous speaker, Professor Larsen, for the very interesting talk. And I will talk a little bit about the same, but I will take a bird's eye view. And I will talk about sustainable energy supply in rural Arctic communities. And my presentation will be split into two parts. First, a little bit about the background, about the current situation in Arctic areas, and then I will focus on the main content about the current electricity mix and generation technologies, and then one issue which is related to energy in the Arctic, that's a problem of affordability of electricity, and another important issue, that's energy security. So first, we can see in the Arctic that we have a very fragile ecological system, and climate change happened 2 to 3 times faster than the world average, and we can see a loss of permafrost, which is melting. One problem is that it's more complicated to construct something, like, for example, later on a wind turbine. And another problem is the release of methane gas, which is an even worse climate gas. So another problem is, as we can see in Greenland, the melting of the ice cap. And the people in the Arctic have, in general, a very strong connection to the nature, and they are living even from the land. So they have a high subsistence level. And as my previous speaker already mentioned, most of these communities are located remotely in Greenland. There are all communities, except of 2, not connected by an over-regional or regional electricity grid. And in Alaska and Canada, we can see the same situation. And these remote communities are approximately powered by 80% just with diesel fuel. And we can also see some impact why a change is needed. First, we can see that there's an impact on the social and economical side, and we can see an environmental impact. But let's first talk a little bit about the social and economical impact. As we heard before from Professor Larsen, that shipping and getting stuff somewhere, it's very complicated. It doesn't matter if it's parts for a wind turbine or diesel fuel. And these harsh conditions make it very complicated to plan such diesel shipments. And in some communities which are inland, we have just the ability to bring it over the open rivers, if it's a bargeable river, or during the winter time when the rivers are frozen, over ice roads, if they're stable enough. And if these 2 methods aren't working, then we have a third option, which is very expensive. And we can see it here in this picture. This airplane is bringing fuel into the community. It's supplying a community in Alaska. And of course, all these methods of transportation are very risky. For example, if the ice isn't stable enough and a fuel truck breaks in, there is a risk of a fuel spill. And the harsh and unpredictable climate condition makes it very complicated to schedule the fuel delivery. And this generates high fuel costs. And this relates to high electricity costs. So we have, for example, the high fuel cost. Then we have to store diesel. So we have to store diesel for approximately 1 year if we just have a very short time frame where we can deliver diesel fuel. And of course, the remoteness. So it's very far away. We have very long transportation ways. And another very important aspect for the social life is reliability of diesel or energy. So if we have in Arctic areas failure and it's minus 20, 30 degrees, then it's a really life-threatening situation. And for example, now my heating is broken down. So for me, it's just inconvenient in Germany, but in Arctic areas, if you sit at minus 30 degrees, then it's a big issue, and you have to gather in a building where you have emergency heating. And another problem, which when I was talking to the people in Arctic communities, they didn't recognize it anymore. But for me, when I was in a very small village in Greenland, I always had this noise of the diesel generator. And for me, it was like a big cruise ship. On the other part, we have the environmental impact. That's a very well-known CO2 emissions and the black carbon, which is a special problem in Arctic areas because it's lowering the albedo effect. And the land degradation if we have a diesel spill. And this can be also traced back in the food chain. And especially that's a problem if the people are hunting the animals and eating it. So now I would like to come to the main content, and I will go a little bit around this paper about energy resources and electricity generation in Arctic areas, which was published a little bit earlier in this year. And I will focus on 2.5 points. So first, a little bit about the energy mix in Arctic areas, then the generation technologies, and then I will touch a little bit the affordability. So for this paper, I was considering approximately a little bit more than 500 communities in the Western Arctic. So in Svalbard from Norway, then Greenland, Canada, and the US with Alaska. And all these communities have no connection to an over-regional electricity grid. And we can see the green dots are representing communities where I got a full set of data. So which technologies they are using, then the generation, the generators, the size of the generators, and the actual production. In blue, the dots are representing communities where I just got a few data, and red dots are communities where, which I identified that they are located, isolated in this area, but no data about the generation are available. So if we see, as already mentioned in the beginning, that 79%, approximately 80% of these communities are 100% reliant on diesel, but we can also see that a share of 6% of the communities are dependent on hydropower. I will talk a little bit about this later, and then we can see approximately 15% of these remote communities are having installed hybrid systems. That's a diesel generator combined with wind or photovoltaic. And these are the results of the analysis of the basic and detailed data. For the next step, I would like to go a little bit deeper and just focus on the detailed data. So here we can see the first on the right-hand side, the installed capacity. And there we see that diesel is with 3/4 the by far dominant energy resource if it takes the installed capacity. Then we can see a share of 23% hydropower and a 2% share of wind. And this is approximately in the Arctic 12 megawatts installed wind capacity. And then we can see a little fraction of solar. But if we take a look on the generation, then we can see a different picture. Then we can see that approximately, very rough, hydropower and diesel approximately the same. So it's 54 compared to 44%. And this is also related to one fact that diesel is used as a backup source. So if we have a hydro community, then we have also a backup diesel generator if the hydropower fails or for maintenance purposes. And another thing which is very interesting, if we remember the previous graph, we saw that approximately 6% of the communities have diesel hydropower, but we can see that a very large portion of this of the actual generated electricity comes from hydropower, and that's related due to the fact that hydropower is mainly installed in relatively large communities and not in smaller communities. So that's why this high share can be reached with a small amount of communities. And then we can see a generation of a wind, which is approximately 28 gigawatts per year, per hour, 20 gigawatt hour. And if we take a look at the next slide, here we can see a brief comparison of 100% diesel-based communities compared to hybrid system communities. Here we can see the population and the capacity factor. And if we take as an average, we can see that the hybrid system have a little higher installed capacity, and that's related due to the reason if there is no wind, the diesel generator still has to supply the community with enough electricity so that everything is running smooth in the community, because it's a very essential source. So now we can see a few different options of energy resources. And diesel, I already mentioned it, it's well proven over the last decades, but we have the environmental issues and the transportation issues, but it's used because it's very easy to store over a long time. We have a high energy potential in a small amount of diesel, and it operates very well under these cold conditions. But we can also see a long experience for a hydropower plant. In the bottom left corner, we can see a hydropower plant of Nuuk, which is operating very well and has reached some more significant cost reduction. And on the top right corner, we can see a solar test site, which is installed in Nuuk in the front of the headquarter, Nukusifit. And at the bottom right corner, we can see a small wind farm, which is installed in Kotzebue in Alaska. And here we can see, as Professor Larsen mentioned, different variation of blades. The wind turbine in the front, there we can see black blades, which are preventing it from icing. And then we can see in the background some older ones with black and also white blades. And on the top left corner, we can see battery storage. So this battery storage is installed in Kotzebue, and this is linked to the wind side. And in the wind side, we can see two different kinds of wind turbines. The large ones there from this kind are two installed. They have a 900 kilowatt installed capacity, and the smaller ones, there are 10 wind turbines with a 66 kilowatt. And we can see that the potential of wind turbines is increasing under these cold conditions. For example, if we have approximately minus 40 degrees, then we can see an increase in efficiency or performance of up to 20%. So that's a huge advantage, of course, for this location. And we have the problem, as before mentioned, that it's a non-dispatchable energy resource, so we can't predict the performance, and we have fluctuations in voltage and frequency. So if we install a high amount of these kind of renewables, of this non-dispatchable like PV or wind, we need some technology as a battery pack to keep the voltage and frequency smooth. But of course, there are other issues related, and that's material properties. Under this very cold climate condition, sometimes some thing can happen. I don't have a picture of it, but this wind turbine, which we can see the column, there was a small problem with the wiring because it got brittle after some years, and there was a small short circuit. And the strong wind can be a problem, and the before mentioned ice formation. So there are some active ways to melt it with, but then you need the electricity you are generating, or you can coat the blades black. And another very important issue, that's construction. And we have very high prices to install wind turbines. And of course, it's depending on the size of wind turbines. And the construction work itself, it's a problem. For example, here on this picture, we can see that the foundation, it's in permafrost, and we have this passive cooling system. So there are holes drilled down, and then there is it's kind of heat exchanger, and the fins are taking the cold out of the air to keep the permafrost frozen during the summertime. That's a very common thing for larger constructions in this area. And of course, but my previous speaker here already mentioned that getting the material, it's a very huge issue how to plan it and to get everything up. So if you just have 1 or 2 boats per year coming to a community, you have to bring all the material, even the 4-wheel loaders or cranes with the first ship, and then you have to bring it back with the second ship. So that's not really very beneficial. And he showed a very interesting picture of the wind turbine in Igaliku, where they can tilt it up with a small ATV or similar machine. And of course, another problem, that's the impact on wildlife, bird strikes, and another issue, especially in Norway, where they have reindeers, it's that the reindeers aren't grazing close by the wind turbines. When I was in Alaska, it was a kind of different picture for me. It was very interesting to see that the local inhabitant really liked the wind turbines because they had the benefit in their pocket. And they said the wind side, it's selected to a very close place to the community to have short overland lines. So there is no hunting ground. So as promised before, I would like to talk a little bit about the cost burden, which is a very important point. In this paper I mentioned before, I just touched it very briefly, but in another paper, which is published in Kunstkamera journal, I talk a little bit more about the dependency on electricity among inhabitants in rural Western Arctic communities. And I always read in the beginning that electricity, it's very expensive in Arctic areas, and I tried to get a feeling for it. And so first I started by looking into the data I got from the national census and the government on the income in these communities, the electricity prices, and the consumption for this community, for residential consumption. And then we can see that there's a huge difference between native and non-native communities. But then when I was thinking a little bit more about the lifestyle of these native people, I remembered when I was interviewing them that subsistency, that's a very essential part of their lives. So somehow I had to include it, and that is represented in this graph. So we can see that the people are hunting approximately 120 to 360 kilograms, and this gives surplus to the income. And then we can see that it's a little bit more affordable, but still we can see that a few communities are peaking out. And the majority, it's below 10% of the net income. So one point I have to mention, it's for the why there is a difference between the indigenous and non-indigenous people. That's because the non-indigenous people are often coming there for work, and they have jobs at mining or oil platforms. And the indigenous people, they often have temporary jobs or even unemployment. It's a very common issue. Now I would talk a little bit about energy security. So energy security means, as you all know, the uninterrupted availability of an energy resource at an affordable price. And that's a very important point, the affordable price in Arctic areas, as before mentioned. But we can see also different time horizons for energy security. We can see a short-term energy security, then it's a very specific point, it's a midterm and a long-term energy security. And the short-term energy security, it's more the stability of the grid and the responsiveness of the grid, that we have that the voltage and frequency is smooth, and we have a good energy quality. And therefore, if we have a high amount of renewables, if you have a high penetration above 20%, then we need something like a flywheel or battery storage to keep the voltage and frequency in the levels. And if we can take a look at the hybrid system, we can see that the diesel generator is doing this pretty well, up to 20%. And of course, we can see that of the installed capacity, approximately 50% is for backup. So we can see that we have several generators often in the communities. It's common to have 3, so that one generator is running for the summer load, which is lower than the winter load. In the winter, 2 generator sets are running to provide enough power, and the third one is for backup. But these generator sets are used in a relative way, so that the hours they are running, it's approximately the same, so that they are aging the same level. And midterm energy security, that's something which I was already mentioned before. That's specific to the Arctic, and that's related to the fuel security. And there, renewables can help to lower the dependency on imported fuels by using locally available energy resources like wind or solar energy, or even hydropower. And long-term energy security, that's about the environmental issues and political planning, for example, for targets for renewable energy. And one very important point to mention, it's the affordability, which is also linked to these long-term policies. So we can see that the prices are as high as $1.80 per kilowatt hour in Alaska. And if you compare, I don't know the prices in Denmark, but in Germany, it's approximately $0.25 cents or $0.28 cents. I think in Greenland, it's, since the unified price, also a very low. So that's a huge cost burden in some parts of the Arctic. So let me conclude now, since I'm running out of time. So the energy security can be reached by a diversification of energy resources, and therefore renewables are very essential column to reach this. And renewables can help to make the energy price in these communities more robust due to diversification and less need of imported fuels. And especially if we see that some CO2 taxes might coming, or prices at the stock for fuels, that's a huge impact for these communities. So that results in lower electricity prices. And of course, this helps the local community to lower the cost burden of electricity prices. So that was my presentation. Thanks for your attention, and I'm welcome to answer your questions. And I would like to thank for all these communities who showed me their energy generation facilities and warmly welcome me. And of course, my funding sources, Iceland Research Fund and Landsbecken Fund.
Thank you very much, Magnus. Are there any questions for Magnus de Witt?
Yes, I would like to ask Magnus Esben Larsen. You're talking about the prices. From my experience in Greenland, there's a quite large difference between production price and the customer's price. I think you're discussing the scene from the customer point of view and not from Reykjavik's point of view, the cost of production at these specific locations, because some of these very small locations, then the resulting production price for a kilowatt hour can be 3, 4, 5 euros per kilowatt hour. But because of the political decision, then it's the customer's price is about less than half an 0.5, 0.4 euro per kilowatt hour or something like that. Yeah.
Yes, that's why I was taking Alaska, because it's much easier or precise to take the data. Because in Greenland we have first the unified price for the customer, for the cost burden of the customer, and then we have it was very hard to get actual data about the fuel prices, because they have this they buy it in bulk, and they have this how is it called, with this polar
oil.
Yeah, polar oil.
Yeah.
So they have, you don't get the actual fuel price to calculate it, which they have in the community. You just get the polar oil price for whole Greenland. But I know from Reykjavik that there is a huge difference between the sell and the production price.
Thank you.
Thank you, Esben. Are there further questions? But anyhow, I have a comment, and I will say thank you very much for the presenters for this paper. I think it is very important to have some numbers on what is actually going on and what can be done, because it seems as the Arctic has been a place which has not been having very much attention until now, and of course that's also one of the reasons why we are taking this up right now. We will soon have go to lunch, and after the lunch we will continue. We will have this lunch break till 14 hours. That means about 35 minutes from now we'll be back. We are a little bit delayed, so we have to shorten the break now, and I hope that it will be all right with all of you. But we'll be back at 14 hours CET, and that will means wish you bon appetit.